This problem is number 24 from the 2001 AMC8. This is one of my favorite problems. It's a good logic problem that's sort of masking itself as a math problem. And as you read through this, one of the things that is important to recognize is that they don't really tell you where these different colored triangles have to be on our picture. They just tell us how they have to match up. And so you can place them where they go. So I've found on this problem the best way to do it is to actually just create your own example of how this works. So the first thing is make sure you recognize that you have to meet this condition on both sides of the line. And so you have to have 3 red, 5 blue, and 8 white on each side of the line. When you do this, it tells you some facts. It says that there are 2 pairs of red triangles that coincide. So we can just start by putting a red here and a red here and a red here and a red there, and so we've got 2 pairs of red that coincide. And then it says you have 3 pairs of blue triangles that coincide, and so we're going to put in 3 pairs of blue triangles that coincide, and we can do this very easily. Again, it doesn't matter where the red and the blue are, it just matters that these pairs coincide. And then it says there are 2 red-white pairs, and so we have a red pair that would go right here, and then right there, and then we'd put a white here and a white there. Now notice I put one of the red on the upper half and one of the red on the bottom half, and the reason for that was because I had to meet this condition that said 3 red triangles on one side of the line. So if I would have tried to put both red on the top or both red on the bottom, I would have had 4 red triangles on that side. So now I've got 8 or 7 of my triangles placed. It says now how many of the white pairs coincide. Well, you've already done all the red. It says that 3 pairs of blue coincide, and that means that those are the only pairs of blues that coincide. So you have 2 blue triangles for each side that don't coincide with each other, which means the only option is they coincide with a white. So if we put those in, where we coincide 2 blue with a white, so we put in 2 white here, and then 2 white up here, and then 2 blue here to coincide with the 2 white on the bottom, and then 2 blue here to coincide with the white on the top. What is left is 1, 2, 3, 4, 5 triangles that we haven't filled in. We've used all the red and all the blue, 5 red and 5 blue, or 3 red and 5 blue on both sides. So that leaves us with 5 white pairs that must coincide. So the correct answer is B. There are some other ways to do this. You can do this making a chart as a good way to go through and do it. But I like the visual way, and I think it's an important problem-solving technique for competitions to understand when you can make up your own example that helps you solve the problem.